Listen, when we talk about the future, we're not talking about some far-off sci-fi dream. Nope. We're talking about technologies that are breaking into reality as we speak, right now. They're reshaping our world in ways you might not even realize. So let's dive in and take a look.
And look, this isn't some slow, gradual shift. It's more like a series of earthquakes, We're going to look at how we're literally rewriting biology, completely re-engineering our physical world, transforming how we get around and, well, ultimately, redefining what intelligence even is.
All right, first up, we are fundamentally rewriting human biology. And I mean fundamentally. This is a revolution in medicine that goes from programming life at the cellular level all the way to, get this, printing brand new organs on demand.
So, you might be wondering, what exactly is synthetic biology? Well, think of it like this. Imagine treating living cells like they're tiny computers. We're actually learning to write code for DNA, telling microbes to do totally new things. You've got companies like Ginkgo Bioworks already using this biological code to engineer organisms that can produce everything from biofuels to biodegradable plastics. It's wild. Biology is literally becoming a manufacturing platform.
And because of this, our whole medical toolkit is getting a massive upgrade. We're talking about living medicines, right? There are over 30 therapies in trials right now that use engineered cells to fight diseases like cancer. We're even finding brand new uses for drugs we already have, like looking at GLP-1s for Alzheimer's. And it doesn't stop there. We're creating these things called nanozymes, basically artificial enzymes, for almost instant disease diagnostics. Even that watch on your wrist, it's going from a simple fitness tracker to a predictive health monitor that can see problems before they start.
Okay, now to really understand this next part, you have to appreciate the sheer scale of the problem we're facing. Just in the US, over 100,000 people are on the organ transplant waiting list. Just think about that number for a second. It's staggering. And sadly, thousands of people die every year just waiting.
So, the solution? I know, it sounds like something straight out of a movie. But what if we could just replace that donor list with a printer queue? Well, guess what? It's already starting to happen. Labs are producing complex tissues right now. And get this, researchers in Sweden have already successfully implanted 3D printed cartilage into patients. This is it. This is the dawn of regenerative medicine, on demand.
Okay, so just like we're re-engineering our own bodies, we're also fundamentally reshaping our physical world. And I'm talking about re-engineering the very fabric of our environment, everything from the cars we drive to the climate we all depend on.
All right, let's talk cars. EVs have a big problem, a weight problem. That battery pack is heavy. But what if the car's frame wasn't just holding the battery? What if it was the battery? That's the whole idea behind structural batteries. It could make EVs about 10% lighter and give them way more range. And this isn't just some crazy idea on a whiteboard. Companies like Volvo and Airbus are already working on it.
And it's not just cars. Our entire energy landscape is being totally reimagined. So on one hand, you've got traditional nuclear fission, but we're making it safer and more flexible with something called small modular reactors. You can basically think of them as micronukes. Then on the other hand, we're chasing the holy grail of clean energy, fusion. And with almost $10 billion in private money pouring in, you better believe that race is heating up fast. But of course, powering this new world means we have to deal with our climate legacy. And there are technologies for that too, like direct air capture, which can literally vacuum CO2 right out of the atmosphere. The problem? The sheer scale of it all. Right now, our capacity is around 10,000 tons a year. But global emissions? They're nearly 37.5 billion tons. Yeah. Looking at these numbers side by side, it just shows you how far we really have to go.
All right, let's shift gears. Our next section is all about a new age of mobility. We're going to talk about how we'll move around, not just here on Earth, but beyond it too.
So, I want you to forget the idea of one big, clunky robot doing a job. Instead, picture hundreds, even thousands of small, autonomous robots all working together, kind of like an ant colony. That's the essence of swarm robotics. And it's real. In Budapest, they had a swarm of 100 drones showing this off in real time. The potential applications are just huge, everything from monitoring wildfires to precision agriculture.
And what about our daily commute? Well, that's getting automated too. And we're not talking about some closed-off test track anymore. Just in 2023, Waymo's fleet drove over 7 million miles on public roads with no human driver. Over in China, Baidu's robotaxis have already given more than 5 million rides to actual paying customers. The driverless future isn't coming. It's already pulling up to the curb.
Okay, now let's zoom out a bit. Actually, let's zoom way out.
The new space race is officially here, and this time it's being driven by a booming commercial industry. I mean, SpaceX has already launched over 300 missions. By 2030, we're looking at crewed moon landings again from NASA and a full-on lunar base from China. But this isn't just about cool exploration stuff. It's about business, a space economy that's projected to be worth over $700 billion. That's a huge number.
And that brings us to our final section. We're going to talk about the one technology that underpins and accelerates pretty much everything else we've discussed, a new form of intelligence. And the really key shift you have to understand is this. AI is evolving from a simple tool that we use into an autonomous agent that acts for us. So to really get this shift, let's start with the hardware itself. Ask yourself this: what if AI had a brain, not just a super fast calculator? Well, that's the whole idea behind neuromorphic chips. They're designed to mimic human neurons, which lets them run really complex AI using just a tiny fraction of the energy. And Intel's Loihi 2 chip is already out there, proving that this is totally possible.
But you know, some problems are just so incredibly complex that even our best supercomputers hit a wall. I'm talking about things like simulating new molecules for drug discovery, or trying to break next-generation encryption. For those kinds of challenges, we're building an entirely new kind of machine: quantum computers, like IBM's Condor. They're not here to replace your laptop, don't worry. They're being purpose-built to do one thing: solve the unsolvable.
Okay, so all of this, the new hardware, the new power, it's leading to a major inflection point. We're projecting that 2025 is going to be the year that AI stops just answering your questions and starts acting on your behalf.
So what does acting really mean in this context? Well, it means AI agents will be able to do things like research really complex topics for you, book your entire travel itinerary, trade on financial markets, and even manage whole business workflows. And the key part? All with minimal human oversight. You've got companies like Cognition building AI software engineers, like one called Devin, that are designed to do exactly that.
There's a quote that just puts it perfectly. The real disruption isn't chat, it's automation at scale. Think about that. We're shifting from an AI that's just a clever chatbot you talk to a whole workforce of autonomous agents that you can delegate actual work to.
And all of this, of course, leaves us with a massive, and I mean massive, question. As these incredibly powerful AI agents start to act for us, freeing us up from tasks both big and small, what will we choose to do with all that time? That's the world these technologies are building, and they're building it right now.